have a congruential equation here, and we're trying to find out if there's any integer solutions. A, B, and C are integers. And so the approach on this is a little, I guess it's relatively normal. We establish a result about squared numbers of modulo 8 right down here. Now, it turns out a squared number is congruent to 0, 1, or 4. Now, it's enough to look at all of the remainders upon division by 8. 7, 6, 5, 4, 3, 2, and 1. It looks like I left out 0 here. But those numbers, 0, 1, 2, 3, 4, 5, 6, 7, are the only possible remainders when you divide by 8. So this is sometimes called remainder arithmetic. Now, so this limit here really turns out to give us quite a bit of information on how this is going to go. And what I did is just verify that this is just kind of the caveman way of doing it. I checked for every value, 0, 1, 2, 3, 4, 5, 6, 7. I did the squaring. Now, folks, right down here, 49 is congruent to 1 mod 8. It's understood the arithmetic down here is done mod 8. So if you take a look at this, this means the very same thing as 49 minus 1. Okay, 49 minus 1 is equal to what? 48. But notice that is a multiple of 8. That's equal to 6 times 8. Putting the dot here, folks, 6 times 8. So that's a meaning also. Some people like to write it like this. 8 divides 48. Okay. And y'all, that vertical bar means divides. The integer divides the other integer. Now, so now, of course, I'm not going to go through all that arithmetic, but if you go all the way across here, you can see your only remainders are 1, 4. Here's 1 repeating. 0, 16 is divisible by 8, obviously, with a remainder of 0. 9 also has a remainder of 1 upon division by 8. 4, all the way out, folks. So these are the only possibilities, 0, 1, and 4. Now you can kind of see what's going to happen right here. We're dealing with the sum of 3 squares right here, and we want to know if that can be congruent to 7. Well, it's pretty clear just by looking at this limit without writing anything down, the answer would be no there. Now, for example, you could come relatively close by doing this. 1 squared plus 1 squared plus 4 squared, right? It's a possibility. But you see, that's not going to get it done, right? Because this is not congruent to 7, right? It's close. You get 4 plus 1 plus 2 is 6, right? But that's not congruent to 7. Now, other possibilities would be maybe 0 squared plus 4 squared plus 4 squared. You see, this is as close as it's going to get, right? That's also not congruent to 7, right? Okay, so what we've established right here, and again, there's no other way you could get anywhere. These are as close as you can get. 4 plus 1 plus 2 is 6. 4 plus 4 is 8, but you're never going to get a combination where you have congruence to 7. Okay, and so the answer is there are no solutions. Okay, no solutions to this. There are no A, B, and C that satisfy the condition. So we can just say no solution. It's an impossible equation. No solution based on this kind of fortunate result that you only had 0, 1, and 4 as your possible remainders. Let's circle this. And that's